By now, you know that anything that I sign on the homework, it's fair that I put it right back on the test, right? So if you don't have questions, you better ask. All right, Randall, what is 109?
It gives you an equation for the horizontal distance of a projectile, and that equation is r of theta equals v subscript 0 squared sine 2 theta over, and that's all over g. And
let me go back and kind of, so you said this is horizontal distance, right?
I think so.
Okay. And then theta is what? What's theta?
Is the angle of elevation.
Angle of elevation. Okay, perfect. All right, part A.
And it also says G is acceleration due to gravity.
So gravity.
It's 9.8 meters.
Oh, so they gave it to you?
Second.
Okay, so 9.8. Do you guys know the measurement for gravity?
No.
Okay. You know how like in the book it says 9.8, Randall, one more time? Meters
per square second.
Right, per second square. That the square, that power right there, just a unit of measurement for gravity. Okay, just like area, we always use like, for example, unit square, right? But we don't take that unit square into account when we do calculations. Is that understood? All right, so we have gravity 9.8. What else?
And for part A, it says the initial speed is 34.8. Some sort of unit. I didn't write the unit down. And it says what angle of theta is necessary to reach a distance of 107 meters.
Okay, so guess what you'd use for that initial speed? What is that really going to represent here in this problem?
V.
Yeah, because that's initial velocity. Speed and velocity are almost the same, okay? So we're going to do, I'm sorry, that was 34.8. And this is, in the problem, is square, okay? Then now we have sine of 2 theta. So now this is really the real equation, okay, Randall? Okay. So it says, hey, the horizontal distance is 107 equals. Now, bust out your calculator. Oop, 48. 34. Oh my gosh. 34.8 square. Sine of 2 theta all over 9.8. So y1 and y2. So guys, do me a favor. Enter in this as y1. Enter this in as y2. Okay. If you don't know how to use a calculator, practice. And then you're going to have to determine your x min and x max. And also the mode. What mode do you want to be in? Radians or degrees? Huh? I don't know. You can choose. Degrees. Okay. Why not? It didn't say. Okay. It didn't say, and it's an application. So you can choose. I will accept either. Okay, because I can understand both. But if you're dealing with like a normal person on the street, which one do you think that they will understand better? Probably degrees. Okay. Now, because this is the angle is theta is the angle, and that's your input. What should the angle be? How many degrees? You have to think, and you have to decide. What should x min be in your calculator?
0.
Probably 0. Sounds good. This is an application. Can you have negative angle? No. So what's the most degree we're going to have?
180.
You're right. Partially right. Okay. But think about this. What's this over here? What do you think? Where would 180 degrees be on our planet? Remember, this is application, right? Huh? Behind us or in front of us? Yeah, would we need that? Would you agree with that in terms of this application? So what's the most degree that we're going to have? 90, okay? So 90 degrees. So this is 0 degrees and 90 degrees. All right. Since you've entered in x min and x max manually, what button do we press now? Zoom fit, okay? Okay, try it. Do you have a picture? Did it give you a nice picture or no? Slowly coming up. How many times do they intersect? Twice? Okay, find the answer for me. What are the angles of intersection? If you have the first answer, just shout it out. I'm just writing it.
29.99 and 107.
So 29.9999, what does that be? 30, okay. And then the other one? 60, okay. All right, part B. How many parts?
I didn't write down the other parts.
Oh.
I was kind of just stuck on the first part.
In the future, write down all parts.
Right.
All right, who has part B? By the
I think we're supposed to find the maximum distance.
Oh, well, you have it on the calculator. Could you find the max? Max distance, right? Not angle? Okay. Max distance, that means I'm looking for R of theta. All right, find max. Give me an answer. Second trace, maximum, right? Right bound, left bound. So once you have a maximum, what is the... Are you going to look at the input or the output to answer this question?
That's for maximum distance, right?
Uh-huh, maximum distance, the output. All right, find the max. Give me the output based on your calculator. When you have an answer, spit it out. Dude, this is your question, Randall. Find the output.
$123.58
Is it feet or meter?
meters.
Meters. Is that confirmed? Yes, no, maybe? Okay. C for cat?
No, it went round to 0.6.
0.6. Okay, make sure we round correctly. Okay. What is the next part? Where are we stopping? D, E, F, G, H, I? C? Okay. What's part C?
It says to graph.
Oh, now when you are asked to graph it, what are you going to label? X-axis.
Verify with graphing utility.
Yeah, that just means that we're going to copy. Okay, X-axis, how do we label this? What are we labeling?
Angle.
Angle, you're right. And you put in degrees, right?
Mhm.
Okay, what is the Y, y'all?
Horizontal distance.
That's right, horizontal distance. Okay. Does it look like a parabola, by the way?
Kind of.
Kind of, like that ish. Okay. Okay, there you go. All right, other parts, yeah.
For part A, I didn't graph it. I just like did the equation thing, and it only gives you one answer because that's all it knows how to do with the inverse sign. But
then you need to add a period because the period is 2 pi divided by 2, so that's a pi. So you add. So
okay.
so you have to have 2 answers, yeah.
Yeah, but I didn't. Do you just know that because it's inverse sign? You have to.
Well, you're borrowing sine inverse
Yeah.
to solve. So that's why they only give you one answer. But because the regular function is sine, so that means you know it has to be here and here, right? Normally. If the period is normal, but the period is now shrunk. Okay? So what's happening is that, hey, if you solve it normally, you should have these 2 answer, and then you need to take into account the period. Okay? So you will always have 2 answers based on the location of it. Okay? All right, other questions? Yes.
It's not a question, but my graph doesn't look like.
Did you put the window in correctly? What's your window, dear?
I think I put the window wrong. But
Yeah, check the window, check the mode. This problem, we talked about mode being degrees, so make sure that's correct.
that's
Okay,
weird. I put the window in right. Didn't,
what is your mode?
wait, let me switch that.
Okay, and I'll help you. 93? Okay, what is that, dear? 4 sine square x minus 3. What am I
I'm
doing?
trying to find the zeros.
Finding the
And
What
the
is it
thing
equal
is-
to?
f of x.
So we're trying to find the zeros.
How many parts are
The
there?
intervals zero. Just one.
Just one. Okay, find the
So
zeros.
The intervals are 0 to 2 pi.
Okay, that's important, right? Why?
Inclusive.
Both ends?
Yeah.
Oh, wow. Okay. All right, so find the zeros mean, what do you do if you don't have a calculator?
Yeah, plug zero in.
Plug zero in for which?
Is
F of x, that's right. So here we go. 4 sine square of x minus 3 equals a 0. Can I add both sides by 3? And then divide by 4? Okay. So I'm just going to quickly jump to the bottom. Is that okay with you guys? Now, what do you do?
Wait, never mind.
Never mind. What did you do wrong?
I don't know. I just wasn't thinking. I think because it got it down.
All right, did you guys root it?
Yes.
And then you do plus or minus?
Yes.
Then you have 4 answers?
Yes.
Good. All right. Next.
Can we do 91?
Yeah, I can do whatever you want. 91.
Okay, so it's 6 sine x minus e to the x power. equals
Sine
2.
x minus e to the x power equals
2.
2. All right, calculator?
X
or not?
is greater than 0.
X is greater than 0. All right, do me a favor. If you didn't know how to do this, do it now. Y1 and Y2. Punch it in the calculator. Mode. What is mode? Radians. Yep, mode. Radians, okay?
How do we determine if it's radians or degrees? Do we like only go degrees if it specifically says degrees?
Correct, correct. Even in the application, you can still choose radians, but your window's got to be a lot smaller.
Yeah.
Okay, so in an application and it doesn't really say what it wants, then you can pick. Now in a normal like practice problem, you usually go degrees if you see a bubble.
Alright.
Mostly it's just gonna be radians. Okay. Okay, so y1, y2, are we good? Okay, now x min, you have to decide x min. What is x min going to be based on the problem? 0, it said so, right? Now x max is where you're going to have an issue because it says greater than 0. It doesn't say where to stop. Where should we try? What should we try? What should we do of x max? Huh? 3? Remember, that's 3 radians, right? Can I, yeah, you can do 3. But can I try the first revolution? I mean, first period. Would that be okay? Yeah. When you try it, when you try the first circle, first revolution, and if it's too big, can you always adjust it? Because they didn't tell you where to stop. So always try a full circle first. When you hit zoom fit, are you able to see where they intersect? No. Then that means you should try what? Pi. Yeah, try pi. Okay, then hit zoom fit again. Now, if you still can't see it, then analyze your equation. Can you see that I'm really interested when y is exactly what? 2, right? Look at your window. Hit window really quickly. Do they give you a bunch of negative y values? Yeah. Do I care for all the negative y values? No. Change it to 0. And then hit graph. Because I'm only interested in the positive y. So hit graph. No more zoom fit once you change it. Now, do you have a better viewing window? How many times do they intersect? 2, so you have 2 answers. Okay, so give me the answers when you have it. So they intersect at when x is and x is. I'm sorry, what? 35, 1.35, and what's the other location?
0.76.
Huh?
0.76.
0.76, okay. Any questions of what do we need to do for the calculator? All right, other questions?
For 79, I got 2 answers and I was confused why it was no solution.
Okay, what's 79?
Secant squared theta plus tan equals 0.
Tan of theta equals 0. Is that okay? Can I convert one of these?
Yes.
So which one can you convert? Good. What is secant square always?
Plus tan squared.
Good. And then I'm going to drop this down because now they're all common trig function. This is going to be easy for me to solve. I'm also going to write it in order so I can see if I can factor. Is this factorable? No. Now, if it's not factorable, it is not immediately no solution. Is that clear? All right, now I'm gonna change this. I'm gonna let this be u, x, whatever variable you want to use. I'm just gonna use u. This is not factorable. Can you guys see that? In Algebra 1, if it's not factorable, what else should we try? Quadratic, right? Because that's x squared, excuse me, x equals negative b. So here we go. U equals negative b is negative 1, right, class? Plus or minus, big radical. B squared is still 1 minus 4 times a, which is 1, times c is 1 all over 2 times 1. Wow, check out under the radical. What's up with that? It is? It's imaginary. So therefore, this is the reason why we do not have an answer. Okay, so no solutions.
Because I solved it a different way, not using the quadratic.
Sure, talk to me through it. What did you do from here? And then
At the beginning, I transferred secant to 1 over cosine squared theta.
1? Oh, yeah, that's legal.
And then added that to sine theta over cosine theta.
Yep, that will work.
And then equals 0. And then next step, I made sine over cosine a common denominator. So
Sure.
I did both the numerator and denominator times cosine.
Beautiful. Yep, that's legal.
And then added them together.
So you got 1 plus sine of theta times cosine of theta all over cosine square of theta equals 0?
Yeah.
Yep, that'll work. Now what?
Oh, that's what. Okay, never mind.
Okay. Yep, so far so good.
Yeah, I crossed out the cosine because I think I forgot about the 1.
Oh, yeah,
And that's
no.
why, yeah. Okay.
Okay.
95 part D.
95 part D. I'm just going to ask you for all of 95 because it's going to be related. Okay, so let's start with the problem.
It's f of x equals 3 sine x.
3 sine x, like that?
Yeah.
Okay, part A.
And part A says find the zeros of f on the interval of negative 2 pi, comma 4 pi inclusive.
Okay. Find the zero, meaning that I'm going to do what? What are we doing? Yeah, and solve it manually. This is no calc. Problem like this would be no calc, okay? So here we go. 3 sine of x. Can I divide both sides by 3? Yep, so that means it's still going to be sine of x equals 0. So where would x be? From negative 2 pi to 4 pi, where are the locations? X is at? Yeah, would you agree it's like right here? Right? In the unit circle? So 0. I'm going to positive direction first. Is that okay? Pi, 2 pi, what else? 3 pi and 4 pi. Then I'm going to go negative direction. So would you agree that's negative pi and negative 2 pi?
Yes.
Okay. So you can continue. Negative pi, negative 2 pi. Now if you are kind, you can put it in the smallest to biggest. Okay. Part B?
B says graph f of x equals 3 sine x on the interval of negative 2 pi 4 pi inclusive.
Perfect. Negative 2 pi. And this is a great question. I mean, what an awesome question. Like, really great. You know? Like, what a beautiful question. Just saying. You know? Yeah, it has everything. It has solving. It has graphing. It has finding the zeros. Oh, my. Gosh. All right. Each period, I'm just going to go in and give it 4 even intervals, okay? A sign start to 0, 0. Okay, then I'm going to shoot up at 3 because that's the amplitude. When you're graphing, make sure you have marks, dots correctly. Label if it's not 1. Notice how I'm labeling. I don't need to label every tick mark. Can you guys see that? But I did label 2 pi and then 4 pi. So you guys know, or my teacher would know, that the X tick mark is not by 1. Okay. All right, so here's my graph. And then any application in the homework, it's a fair game. All right, so there it is. Now I'm going to quickly check to see if my part A is right. Notice how part A has 2, 4, 6, 7 answers. Do I have 7 zeros on the graph? Yeah, so that's how you can quickly check, okay? What's C?
C is solve f of x equals 3 over 2.
F of x equals 3 over 2. Okay, so now,
And what points are on the graph?
okay, so what points on the graph? So what do we do here? How do we solve f of x equals 3 over 2? Yeah, so I'm just going to set it equal to my equation. Is that okay? 3 times sine of x. How do we solve it from here? Oops. Divide both sides by 3. Can I times it by 1/3? Yeah, I'm going to do that. So now I really have 1/2 equals sine of x. Is that okay? Sine of 1/2 is going to be here and here, right? So this is pi over 6, and this is 5 pi over 6. Okay, so that's just the first period. Can we all agree with that? Okay, so x is going to be pi over 6, comma, 5 pi over 6. But I look at the right side. Don't you see that we go in 2 periods? So can I add, what's the period on this? 2 pi. So that's really 12 over 6. So what would that be now? 13 pi over 6, and then 17 pi over 6. Now I also need to go negative cycle. Can we agree? So what is that angle right there, negative direction? Negative 7 pi over 6. And what is that angle right here?
Negative 11 pi.
Right. Okay. So, and then it says, what are the points? Well, the point just means that I just need to write it as points. X comma y. What's the y value for all of these points? Yeah. Right. So I'm going to need to write 2, 4, 6. 6 points. 1, 2, 3, 4, 5, and 6. Okay. Can you guys write the points on your own? Yeah. All right. Part D for dog. This is the part that you really wanted.
It says, use the graph drawn in part B along with the results of C to determine the values of x such that f of x is greater than 3 over 2 on the interval of negative 2 pi, comma 4 pi inclusive.
Beautiful. Okay. So it says, hey, find x values when y is greater than 3 over 2. I'm going to graph the line really quickly. Can you see that this line is about y equals 3/2? Okay, so I'm going to zoom in because that's what I'm going to focus on. If it's looking for what x values when f of x is greater than 3/2, is that above or below? Above. So I'm going to get this. So would you agree that's above? That's also above. That's also above. There are infinitely many solutions, right? So how do we quantify those? What would you write? Where do we start?
So this one's just limited to those 3 because it's within.
Oh yeah, but there are, even though they're limited to just those 3, but like there's infinite many solutions I can write. So I can't write it as like x equals pi over 7, or you know what I mean? It has to be an interval notation. Does that make sense? So where do we start? Let's go from negative. What is this first dot right there? Yeah, so it's negative 11 pi over 6. And that goes all the way to negative, right, negative 7 pi over 6. Okay. Then I'm going to keep on going, right? This right here is what? Pi over 6. All the way to 5 pi over 6. Okay, and then last interval, 11, wait, 13? 13 pi over 6. All the way to, there you go. Yeah, so those are them. Okay. I mean, on the test, could I ask when is it less than? Would that be okay too? Yeah, okay. Conceptually, it should be the same. Other questions? Going once? Yeah, Johnny. They would not be, a very good question by the way, because at 3 pi over 2, okay, I'm sorry, I'm not at 3 pi over 2. At these location of x right here, I'm going to highlight. Can you see that? At those location, the output is exactly 3 over 2, which is not greater than. Comments or questions? Okay, that's the end of homework questions. Grab a book, start on today's.